Hello, everyone, and welcome back to the FUNWAVE application on the ERDIC HPC portal. This tutorial will focus on the second tab within our simulation workflow, the Bathymetry and Topography tab. So here we'll discuss some different types of bathymetry that you can set up in this tab, as well as some tooltips available within this section. So recall that we have 5 primary tabs in our simulation workflow. That includes the Overview tab, the Bathymetry Topography, Input Output, Run, and Post-Processing. So in this Bathymetry Topography tab, we have 2 primary sections here. We have Topography and Bathymetry. So in the topography section, we can define the total size of our numerical domain. And in the bathymetry section, we define the actual bathymetry/topography configuration of the domain by selecting one of these depth types. So let's start here with the depth type, and let's talk about the different ones available in this portal and within FUNWAVE. So the default depth type that we see here is the flat type, which, as the name suggests, that means everything within the numerical domain is at one particular water depth or one particular depth. So this might be useful for some idealized cases or testing cases or simulations for your purposes. So with this particular depth type selected, the flat type, we have 3 variables available to fill in. So the first that we would want to provide is our step size or discretization of our grid or numerical domain. And in this case, that is dx and dy. Because we are using or showing an example of a 2-dimensional simulation, we have both the dx and dy to adjust. Otherwise, in a 1-dimensional simulation, we would only have the dx variable to adjust. And so we also have this water level variable. So this variable will change depending on which depth type is selected. So for the flat type, because we assume that the water depth is the same everywhere in the domain, this water level variable defines the total water depth that you'll find everywhere in the domain. So water level of, say, 8, this would mean that the water depth is 8 meters everywhere in that domain. And so we'll show an example of when this value changes for a different depth type later on in this tutorial. So let's keep those as our options. So now that we have made changes to any of these variables, we are going to remember to save our changes with this little red save icon in the bottom right corner. And when we do see we get a little notification saying that the data has been saved. Now, if you do end up forgetting to save your changes before moving to a different tab, say, for example, I were to change the water level to 10, I say, okay, that's great to go. Let's move on to the other tab. You will get a notification saying that you do have unsaved changes, and you will be prompted to go return to that previous tab to save those changes. So we'll just click OK. Go back to our bathymetry tab. We do see that information is still there, but we just need to hit that save button to write it to a file, essentially. So that's the flat bathymetry type. Let's look at another type of bathymetry that is native to FUNWAVE, and that is this slope here. So we changed our depth type to slope, and we still have these variables dx and dy to define our spatial resolution in the x and y direction respectively. But we also have these 3 additional variables to fill in. So the first is this slope condition. So this slope variable defines the angle of your incline in the domain. So a slope of 1 would be equivalent to a 45-degree angle or incline to the shore. And if we hover over this info icon, we're recommended that the slope be no larger than 1, as this causes instabilities in the numerical formulations. So consider having slopes less than 1 in your simulations. Now this XSLP variable, if we were to hover over this info icon, this is the physical location in meters of the toe, or at the point where the incline or the slope starts from your left boundary or your west boundary relative to your numerical domain. So if I were to set this to 80 or so, this would be 80 meters. The first 80 meters of your domain would be flat. And then at that 80 meter point and beyond, that would a slope of 1, or that 45-degree slope would start in your domain. Now this variable depth flat is the water depth of your flat area. So for those first 80 meters, it's at a particular water depth, and this would be the place where you would define that. So that would be like 8 meters here from our previous example. And so now this water level parameter, at this point, this is where this variable changes meaning. So in this particular example, we set our water depth for our flat condition with this depth flat variable. Now this water level variable defines any changes to the mean water level. So this could actually be treated as an initial tide or surge within your simulations. So essentially adding an additional layer of water above the mean water level. So for example, in this particular case, we could set that to 2. And so that would mean that the entire distance below the free surface would be 10 meters. So 8 meters here for the depth of the undisturbed water depth, and then 2 extra meters of surge or tide added to that. And so if you do want more information, feel free to hover over that info icon and redirect yourself to the wiki to learn more. So if we were to move forward with this particular slope example, let's go back up to the topography section to define the total number of points in our X and Y directions respectively. So in this case, let's say that the total number of points in the X direction that we want is 1,000. And the total number of points in the Y direction is 500. Now, these variables, in combination with the dx and dy variables, define essentially the physical units of your numerical domain. This dx and dy essentially translate these total number of points into total length in meters of your numerical domain. So if we do have 1,000 points in the X direction at a spatial resolution of 1, that means we actually have 1,000 meters in the X direction, or representative of 1,000 meters in the X direction. And in this case, 500 points in the Y direction, and let's say we change our dy to 1.5, that would equate to 750 meters in the Y direction, or representative of 750 meters in the Y direction. Let's save our changes. And let's just take a look at this third option, this checkbox for Bathy correction. So if we check this box, we have 2 additional variables that appear, this smooth below depth and slope cap. And really, this feature is best described by going to the FUNWAVE Wiki. So if we were to hover over this icon, the wiki page would load, and here we'd have this really nice graphic or schematic that really describes what the bathymetry correction is actually doing. So we have these, if you are interested in the bathy correction, there are these 2 variables. If we were to look at the slope cap, for example, it would essentially be the maximum slope that would be considered in your bathymetry. So a slope cap of 1 or 45 degrees, that means anything in your bathymetry that is steeper than 45 degrees or is steeper than a slope of 1 would be smoothed out and fit to that slope of 1. So kind of be scrubbed out and would be redefined as a slope of 1. And that option, that process would be performed at every point or anywhere below this smooth below depth variable. So if we went back to the FUNWAVE portal, we have our slope cap of 1, let's say, and then this smooth below depth at 0. So what does that mean? So a smooth below depth of 0 means that anything below the mean water level or free surface would be smoothed to meet that slope cap condition. Well, if we were to set this to -1, well, actually, let's go back to the wiki to see what we mean by there. So FUNWAVE is one of those models where in the bathymetry, all positive values signify points that or depths that are below the mean water level. So the mean water level would be 0 and positive values would be below the mean water level, and negative values would signify points that are, or heights or depths that are above the mean water level, so essentially land points. So if we were to set this smooth below depth to a negative number, say -1, that would mean everything 1 meter above the mean water level and below would be smoothed out to that slope cap depth. So that's this is a nice graphic and a good explanation of what that bathymetry correction is doing. Definitely check out the wiki for more info if this applies to your specific application. So that is with the bathy correction on our slope type. Well, we also have this last bathymetry depth type, which is the depth type of the data. So let's check off that bathy correction and see that the data depth type will actually prompt you to upload a depth file or a bathy file. And this file should be of the same size as your M globe and N globe, so number of points in X and Y respectively. And this file will be an ASCII file or a text file where the number of rows would equate to the total number of values in X, so that would be 1,000, and the number of columns would be the total number of points in Y, which would be 500 in this case. And then with that uploaded file type, you would still provide your discretization in X and Y respectively for this 2D simulation, and you would still have the option of adding this additional water level to your domain. So a new feature that pops up when we do have this data depth type bathymetry is this grid interpolation. And this is actually a new feature to version 2 of this portal application. And this actually allows users the ability to interpolate your existing grid onto a new grid with a different step size or discretization of a lower or higher resolution. So if we click on this checkbox, we have some features. And so to use this feature, we would need to upload a bathy file. So let's actually do that. So let's select a bathymetry file from one of the FUNWAVE simple cases. And here I'll just use the inlet shoal simple case, and we'll just do the regular option. We have in the bathymetry files, we have the original depth file here. So if we upload that, and I believe in this example, this had a spatial resolution of 2 and 2 with an M globe of 1024 and an N globe of 512. So with those changes, make sure we save our work so that way the bathymetry file is loaded into the system. So with that bathymetry data saved in there, we're actually able to plot the current grid that we have loaded, and also the option to interpolate this grid to a new grid and plot those differences as well. So let's actually test this plot current grid feature. And this will probably take a bit to load depending on the size of your numerical domain. But this is an exciting new feature to this portal application. We do hope to expand on this feature a little bit more, maybe giving you the option to carve out sections of your grid and resize as needed. But for right now, just having this ability to visualize your current bathymetry and also interpolate is fantastic. So we see here we're able to plot and visualize our current bathymetry / topography of this example. And we see here we have some pretty nice configuration. So we have some nice contours, a nice color map kind of showing the difference between maybe deep water and more land points. Color-coded respectively. And for this particular example, the depth file contains an inlet with like a sandbar kind of in that inlet. So that is the current grid. Now, for the full functionality of this feature is not ready yet. It should be implemented very soon, and that would give you the option of setting a new DX and new DY, interpolating, visualizing, and keeping those interpolated values as your new bathymetry file in this simulation. To help with plotting, there is this stride for plotting variable, which essentially says, instead of plotting every single point in the domain, maybe plot every 10th point, and that will save you some time when plotting in this feature. It won't affect your bathymetry at all. It'll just save time in plotting. So that's something to look forward to when using this grid. And if you do, once this feature is fully available, if you do interpolate onto a higher or lower resolution grid, and you want to keep those interpolation values, definitely make sure you hit that save button so that way that new data is written into your simulation and you're able to carry that forward. So with that, that concludes our tutorial on the bathymetry topography setup, that tab 2 of our simulation workflow. We do hope that this was helpful. Always remember to save your work before moving on to the next tab. And if you do have any questions, please check out the wiki for more information or contact us via email. Happy modeling!